Welcome to Lesson 3.1, Solving Quadratic Equations by Taking Square Roots. As a quick reminder, we have talked about solving quadratic equations by graphing and by factoring. And now we're going to quickly review how to simply take the square root of both sides of the equation to get our solution. Some of these quadratic equations are so easy that you gotta love them, and perfect squares are the easy ones. Here's our quadratic equation, x squared equals 16. Well, that's pretty easy. We take the square root of both sides, and we do need to remember that we get a plus or minus the square root of 16, which simplifies to plus or minus, let me get my pen, plus or minus 4, meaning our two solutions are 4 and negative 4. So we get two solutions. Pretty easy, right, compared to factoring and graphing. It's simply taking the square root of both sides. Now sometimes you take the square root of a number and it's not a perfect square. So let's say the number 8, and you end up with plus or minus the square root of 8. Now in Algebra 1 we left that just simply as the square root of 8. However, in Algebra 2 and all your higher math classes, you are going to need to simplify that square root. So we're going to take a minute here and review how to simplify square roots. So you're going to need a blank sheet of paper. So let's start with a number like 12, the square root of 12. In order to simplify that number, we need to break it down into its prime factorization. So I'm going to break it down into 2 times, let's see, that gives me 6 left, and 6 breaks down into 2 and a 3. So I've got 2 times 2 times 3 equals 12. Circle any pairs of numbers that you have. So here's one pair of 2's. Okay. That pair comes out as one pair of 2's. So a 2 outside the radical, square root, and what's left underneath is the 3. So square root of 12 simplifies to 2 square root 3. Let's try another one. Square root of 18. Alright, 18 prime factorization. I can pull out a 2. What's left is 9, so that gives me 3 times 3. I have a pair of 3's that's going to come out in front of the radical sign, and I get 3 and with a 2 left under. So 3 square root of 2. Here's another one. Square root of 24. Let's see. I can break that down into the prime factorization of 2 times 2 times 2 times 3. I have one pair of 2's that's going to come out in front of the radical sign. And underneath the radical, we will have 2 times 3, and we can multiply that together and get 6. Now let's talk about square roots in the denominator of a fraction. This is called rationalizing the denominator. If you remember from Algebra 1, no square root is allowed to be left in the denominator if you're simplifying. So we have a quotient property that says if we have the square root of 5 over 4, we can separate that into the square root of the numerator over the square root of the denominator. Square root of 5, I cannot simplify any further, so I'm going to leave that square root of 5. However, the square root of 4 is 2. And so I get square root of 5 over 2. Let's try another one. Square root of 50 over 16. Well, that gives me the square root of 50 over the square root of 16. Now the square root of 50 I can simplify further. I can prime factor that as 5 times 2. There's a pair of 5's that I'm going to circle. In the denominator, the square root of 16 is just 4. So I'm going to pull that pair of 5's out front as just a 5 with the square root of 2 underneath all over 4. Please notice that the 5 and the 4 are not underneath the radical. Therefore, you cannot simplify the 2 underneath the radical with the 4 that is outside the radical. So let's try another example in which we have to rationalize the denominator. Let's take the square root of 1/2. If I simplify, I simply get the square root of 1 over the square root of 2, which gives me 1 over the square root of 2. But if you recall, we cannot leave a square root in the denominator. Therefore, we're going to multiply the numerator and the denominator by that square root that's in the bottom. So the 2. And multiply, if you remember your fraction rules, multiply across the top and you get the square root of 2. Multiply across the bottom and you get the square root of 4, which we know will simplify to the square root of 2 all over 2. And we have an equivalent expression that has been rationalized. So let's go to the next page, in page 114, and they give you a table that explains how to simplify square roots. There's also an example down at the bottom of rationalizing the denominator, in case you forget. Let's go to the next page, and let's see how this works with example A. So notice that what we're starting with, you're actually starting with 2x squared minus 16 equals 0. All right, we need to isolate the x squared, the perfect square. So you're going to add 16 to both sides, divide by 2, and you get 8. You take the square root of both sides, you get plus or minus 8. Don't forget that plus or minus. And the square root of 8 does simplify to 2 square root of 2. So let's try one together. Looking at example B here, the original equation is negative 5x squared plus 9 equals 0. So we need to begin by isolating that perfect square. So we're going to subtract 9 from both sides, divide both sides by negative 5, so that would give me a positive 9 over 5. At which point then we can take the square root of the left side and the right side, where we get x equals plus or minus, don't forget your plus or minus sign, the square root of 9 over 5. Now we can simplify the numerator there as 3 over the square root of 5, but we need to rationalize that denominator. So I'm going to write that as 3 over the square root of 5, and we're going to multiply the numerator by the square root of 5 and the denominator by the square root of 5. And simplifying, in the numerator I get 3 times the square root of 5, and in the denominator I get the square root of 5 times the square root of 5, which is the square root of 25, which just simplifies to 5. I'm going to write that step off to the side here, so you can see where that denominator came from. Alright, it's your turn to practice with numbers 3 and 4 under your turn. Here is a solution for number 3. Stop the video if you need to. And finally, for this lesson, I just want to direct your attention to the bottom of page 115 under Explain 2. When you're working with a word problem, there are 2 formulas you're probably going to need from physics. One of them is the distance fallen. That equation is pretty straightforward. The distance equals 16t squared, t being time. If you want to know the height from the ground, that is, the height equals h sub 0. That's the initial height, so that would have to be given in the word problem, and you'd have to substitute the number in there for the initial height. So the initial height minus 16t squared. So refer back to these 2 equations when you need to write a quadratic equation for an object that's falling. You'll need to look back and memorize these 2 equations.